Welcome back, everyone, to another deep dive into what your kids are learning at the OCSI this week. This time, we're talking circuits.
We're going to be focusing specifically on parallel
Deep
circuits,
solid circuits.
which is super cool, actually.
Yeah. I have to admit, though, like, circuits were one of those things that I kind of got in school, but, it's been a while.
Yeah.
And so when we talk about circuits, one of the first things that pops into my head is, like, Ohm's law.
Ohm's law, yeah.
But I'd be lying if I said I could, like, define it off the top of my head.
Well, I mean, it's really the relationship between voltage, current, and resistance. And that's kind of the foundation for understanding circuits.
Okay, yeah, those terms I definitely remember.
Right.
But can we maybe break down each one just as a little refresher?
Totally. So think about it like a water system.
Okay.
So voltage is like the pressure in the pipes.
Go.
So it's the force that's pushing the electricity through the circuit.
Got it. So higher voltage, stronger push.
Exactly, yeah.
All right, and what about current? How does that fit in?
Current is the actual flow of electricity. So you could think of it like the amount of water flowing through the pipes.
Okay.
And we measure that in amps.
Okay, so voltage is the pressure pushing it, the current's the flow. So what about resistance?
Right. So resistance is anything that kind of slows down that flow of electricity.
Yeah.
Like imagine a narrow part in the pipe. It's going to be harder for the water to get through.
That makes sense. So some materials resist that electrical flow more than others.
Exactly. Yeah. And that's measured in ohms.
Okay, so that's how those three all kind of work together.
Exactly.
And so I know we're talking about parallel circuits. What makes them different?
So in a parallel circuit, you basically have multiple pathways for that electricity to flow.
Okay.
So it's like having, instead of one pipe, you have multiple pipes for the water to flow through.
Okay, and why is that important? What's the advantage of that?
Well, the main advantage is that if one of those paths is blocked, for whatever reason, like let's say a light bulb burns out, the electricity can still flow through the other paths.
Oh, that makes sense.
Yeah, so it's a much more reliable system.
So if one part of the circuit fails, the whole thing doesn't just shut down.
Exactly.
And that's why we use them in things like house wiring, right?
Yeah, exactly. You don't want one light bulb burning out to turn off all the lights in your house.
Right. So how are the kids actually working with parallel circuits this week at the OCSI?
So they're going to be building their own parallel circuits using things like resistors, LEDs, and wires.
Cool. And I know they have those Arduino workbooks.
Yeah.
Are they using those for this?
They are. The workbooks are going to help them actually, plan out their circuits.
Okay.
They'll have diagrams in there.
So they're not just like winging it.
Mm.
There's a structure to it.
Yeah, exactly. There's definitely structure, but it also allows for them to experiment a little bit.
So they can kind of test out different things and see what happens.
Totally. And then they're going to be using multimeters to actually measure the voltage and current flowing through different parts of their circuits.
Oh, okay. Now multimeters, I remember those from school,
Yeah.
but I'm not sure I could explain to someone how they work.
So basically, a multimeter allows you to measure the voltage and current at a very specific point in the circuit.
Oh,
So
right.
you can see how those things are changing as the electricity is flowing through.
That's pretty cool. So they're basically like getting to be little electricians.
Totally, yeah.
Yeah.
Little detectives figuring out how these circuits are working.
I love that.
Yeah.
And I think it's so cool that they get to actually build these things and not just, read about it in a textbook.
Yeah, I mean, hands-on learning is so important for this kind of thing.
Absolutely.
Mhm.
And, it's interesting because this actually builds on what they did last week, right?
Yes. Last week, they were working with series circuits.
Right.
Which is basically the opposite of a parallel circuit.
So in a series circuit, the electricity only has one path to follow.
Right. And so understanding how those two types of circuits work, the series and the parallel, it's really important for like a foundation in electronics.
Yeah. So it seems like learning about series circuits last week is a pretty good foundation for what they're doing this week.
Yeah, absolutely. It's like building blocks, you know?
Right. So let's talk a little bit more about series circuits just to kind of refresh everyone's memory.
Okay, so with a series circuit, you basically have one path for the electricity to flow through.
Okay. So it's like a one-way street.
Exactly.
Yeah.
Yeah. And each component is connected one after another.
Okay. So what happens if one of those components in a series circuit, like, fails?
If one component fails, the whole circuit breaks.
Oh, wow.
Yeah. So it's like, think about old Christmas lights.
Oh, yeah.
If one bulb burned out, the whole string went dark.
Right. Because it's all connected.
Exactly.
Okay. So that's why parallel circuits are better in a lot of situations.
Yeah, because like we were saying with a parallel circuit, you have multiple paths for the electricity to flow.
Right. So even if one path gets blocked.
The other path can still carry the electricity.
Okay. That's pretty cool. And that's why we use them in house wiring.
Exactly. Yeah, it would be pretty inconvenient if one light bulb burning out caused all the lights in your house to go out.
Yeah, for sure. So let's talk a little bit more about those Arduino workbooks that the kids are using.
Yeah, so these workbooks are really cool because they have step-by-step instructions and diagrams
Right.
that help the kids build their own parallel circuits.
So it's kind of like a guide for them?
Yeah, exactly.
Yeah.
But it's not just about following the instructions.
Okay.
They also encourage the kids to experiment and test their understanding.
So there's room for creativity.
Totally. Yeah, and they can use the multimeters to actually measure the voltage and current.
At different points in the circuit?
Right. And then they can compare their findings to what they learned in theory.
Well, that's a good way to make sure they're actually getting it.
Yeah, it really helps to solidify the concepts.
And I think it's just more engaging than just like reading about it in a textbook.
Absolutely. Hands-on learning is so much more effective.
Yeah, and this week's lesson really builds on what they did last week with those series circuits.
Totally. It gives them a good foundation for understanding the advantages of parallel circuits.
Right, and next week they're going to be taking all this knowledge.
And putting it into practice by building their own traffic signals.
That's awesome. I can't wait to see what they come up with.
Me too. It's going to be a really fun project.
Yeah, and it's a great example of how these circuits are used in the real world.
Exactly. They're everywhere.
So tune in next week for our deep dive into traffic signals. All right, so we've talked about Ohm's law, series circuits, parallel circuits. Now let's talk about how all of this comes together in something that everyone's familiar with. Traffic signals.
Traffic signals are a really cool example of how parallel circuits are used in the real world to make things safer and more reliable.
Okay, yeah, I mean, we all know how traffic signals work, red light, green light, yellow light, but I've never really thought about the circuits behind them.
Right. And it's actually a pretty fascinating application of these concepts that we've been talking about.
So how do parallel circuits actually work in a traffic signal?
So imagine for a second that the lights in a traffic signal were wired in a series circuit, like those old Christmas lights we were talking about.
Okay, yeah.
If one bulb burned out, the whole thing would go dark.
Oh, right, yeah, that wouldn't be good.
No, not at all, especially for a traffic signal. So that's where parallel circuits come in. Each light, the red, yellow, and green, is on its own separate branch of the circuit.
Oh, okay.
So if one bulb burns out, the other lights stay on.
That makes sense. So it's like a safety feature.
Yeah, exactly. It makes the traffic signal much more reliable and prevents a lot of potential accidents.
Right. But it's not just about keeping the lights on, right? There's also the timing of the lights.
Yeah.
How do they make sure that the lights change at the right time?
So the timing is controlled by special circuits called timers. They're kind of like little clocks built into the system.
Okay, and what do those timers do?
They make sure each light stays on for a specific amount of time so that traffic can flow smoothly and safely.
So there's a lot more going on inside those traffic signals than we realize.
Yeah, there's a whole system of circuits working together.
That's pretty cool. And guess what? The kids are going to be building their own traffic signals next week at the OCSI.
I know, right? It's going to be an awesome project. They're going to get to use all the knowledge they've learned about circuits and put it into practice.
Yeah, that's going to be really fun to see. But for now, let's recap what we've learned today.
So we talked about how parallel circuits are used in traffic signals to make them more reliable and safe.
We also talked about how timers are used to control the timing of the lights.
And most importantly, we talked about how your kids are going to be applying all this knowledge to build their own traffic signals next week.
So when your kids come home and tell you about their awesome traffic signal project, you'll actually know what they're talking about.
Exactly. And you can even ask them some questions about the circuits involved.
That's a great idea. And to our Coego parents, we want to thank you for joining us on this deep dive into the world of circuits.
We hope you've enjoyed learning alongside your children.
And we'll see you next time for another deep dive into the exciting world of STEAM.